Hey everyone! Thank you so much for watching another episode of the Weaviate podcast. We know another awesome episode with one of the world's leaders in artificial intelligence. I'm super excited to welcome Sarah Waters, co-founder and CTO of Letta. Spun out of UC Berkeley and the momentum of MemGPT, a breakthrough agentic architecture, Letta enables developers to build and deploy stateful AI agents, agents that maintain memory and context across long-running conversations. There are so many interesting ways that Letta has extended MemGPT that we'll dive into throughout the podcast, as well as the background if you're not already familiar with these things. I'm super grateful for the opportunity to discuss these things with you, Sarah. Thank you so much for joining the podcast.
Yeah, thanks so much for having me. Really excited to be here.
Awesome. So I think MemGPT is just really one of these papers that stood the test of time. So many amazing ideas like this self-editing memory, virtual context management. And so I can't wait to dive into how these ideas have progressed with Letta. But first, you mind maybe setting the stage for our listeners who aren't already familiar with these ideas, as well as kind of your personal journey that's led you to be working on this?
Yeah, of course. Yeah, so I guess just some background on me. I was previously a PhD student in UC Berkeley's RISE lab, or now it's called Sky Computing. And my background is actually more on the system side. So I work with Jan Stoika, who I guess like also was part of like the Ray and Spark projects. But my co-founder Charles and I were both in the same lab. We shared an advisor. And so we actually started working on the MemGPT project. It was kind of mostly led by Charles at the time, but I also helped out with some stuff. And then, yeah, as the project kind of evolved from just memory management to being more of an agents framework, I was really interested in more like the system side of like how do we actually build out agents as like services? How do we like manage and persist state in a scalable way? Problems like that. And yeah, I guess you provide some context on the MemGPT paper, but I think it was basically the first paper that introduced self managed memory for agents. But over time, we've kind of observed like that a lot of this memory management actually needs to happen within the framework itself. And so over time, the project has evolved into what's now Letta, which is actually a general purpose agents framework, but it's very focused on basically context management because we saw through the MemGPT work and other research work that we did that like basically memory is everything. The way that you manage your context is like really critical for building agents. Like if you don't have a good context window, you can't tell like is your LLM bad? Is your context window bad? So we really think it's a responsibility of the agent framework to basically be managing memory, managing context. So yeah, that's kind of like why we ended up going in the direction of building more of like agents as a service that can call tools, can call memory, is very extensible through the Letta project.
Yeah, amazing. So I mentioned before we started recording that I was rereading your recent blog post on stateful agents, and one phrasing is this context compilation. I think I
Hmm.
had done a paper summary video of MemGPT when it came out, and I love saying the operating system for LLMs. I think that was a line that resonated with a lot of people. And so I guess
Hmm.
I just want to kind of ask about your perspective about, I think when it first came out, it was about we only had like 4,000 tokens that you could possibly have in the input window. And so it was very intuitive to think, okay, you obviously are going to need to swap in and out. And
Hmm.
I'm curious if the perspective has maybe evolved into like an optimization perspective. So kind of like you're self-tuning the instructions, or if you still kind of have this like just it's always about context compilation or.
Hmm. Yeah, I think it is kind of similar to prompt optimization in some ways, or it's kind of like an orthogonal problem. I think even as context windows have gotten a lot bigger, at the time of the MenGPT paper, they were very small. Now I think, you have 200,000 context window models that are really, really good. But we've actually seen that it can often be pretty impractical to use that entire context window. And the reason is that once you're actually packing a full 200,000 tokens, like 200,000 tokens is a lot of tokens. It takes you quite a while as a developer to read through that. So if you're trying to understand like, oh, why did my agent do this? Or why was this the output of my LLM? It's pretty hard to work with like that big of a context window size because you have to read over it. You have to understand all the state that's in there. So even as a human, it's pretty confusing handling that much context. And I think there's actually been a lot of recent work showing that feeding your LLM that much data at once actually doesn't work that well. Like the kind of really amazing reasoning and inference that you see at smaller context window sizes doesn't actually translate, even for models that are long context. And so, yeah, I think the performance can be a bit disappointing. And then on top of that, your inference starts to get really, really slow. Like you have to wait quite a while. I forget the exact number, but it's not fast to get back those predictions, and it's really, really expensive. So I think for practical applications, most of the time people want to stay around like 30,000 tokens, even if you do have that additional budget. And so what Letta does is basically, given all the state that you have, so that includes both memories or like external data sources, basically managing like kind of packing the most important things into that token budget that you've set. And yeah, we kind of have like a way that we structure the context window with like having some section allocated to the message buffer, some section allocated to the in-context memory. We also manage like a recursive summary and also like statistics about the external data so the LLM knows when to query out to get that external data. So basically, I think like managing that structured context window is what you refer to as context compilation and what enables you to build your agents with smaller context windows in a way that's still like kind of generalizable.
Amazing. That reminds me. I think there's a paper from Berkeley that came out yesterday about this, like structuring the context window about with reasoning. And yeah, I'm sorry, like all these ideas are coming back to my head. I remember
Mhm.
my first conversation with Charles on the podcast was about like you have these sections of the context window that are like this is the RAG, this is like the retrieve context section, this is like my internal
Mhm.
working memory section. And yeah, that is such a fascinating idea. Yes, I guess I'd want to ask maybe if we could just go a little further into what it means to structure the context window. Is it like how much structure are we talking? Would we just have like
Mhm.
sections for like I meant like retrieved context, working memory, or is there even more structured to it than that?
Yeah, I mean, it's not, I think we basically have like a couple additional components what people beyond what people would normally do. So I think for most agentic applications, you probably have like your system prompt in the very beginning, you have your tool definitions. You might also be using some form of like RAG-based memory. So you might be retrieving like some like five potentially relevant messages, and then you have like the remainder of like your in-context messages. So I think that's how like most agentic context windows would look like today. With Letta, we have like those additional components. So for example, like the in-context memory, you as a developer can also like kind of customize how much space is allocated to each of these components. So you can actually set like a character limit to how big your in-context memory can be. The in-context memory is also divided into multiple sections. So typically we have like both a human section of the in-context memory and then also a persona section. But you can also customize that as a developer. And then we also have like the recursive summarization. So that's basically like if messages get evicted, then we make sure to update that summary just so the LLM kind of has like this ongoing idea of like the full message history. And then yeah, we also we do like agentic RAG, so we do sometimes retrieve back like historical messages, but we only do it if the LLM decides to explicitly call the tool.
Yeah, amazing. There's so many exciting ideas. I'm trying to like pick the next question
Mhm.
cleverly. So, I think maybe it would be interesting to come into this kind of like self-editing prompt, sort of. Like maybe a little bit. I was playing a bit with the Anthropic Model Context Protocol, where it's pretty cool how you can connect Cloud Desktop to say Weaviate, and it will save the memory in your database.
Mhm.
And I'm just curious about this, like what you're seeing with. So you're having a chatbot or you're doing a task, and what is the prompt of like, hey, save some memories, and what kind of things are you seeing? What kind of memories is it saving?
Mhm.
And maybe that's such an open-ended question because it could be anything. But
Yeah, well, I think one thing that's kind of unique about MemGPT and now Letta is that we basically offload the responsibility of memory management to the LLM. So this has some benefits in that like it's a very general purpose approach, and as LLMs get better, that means that memory management gets better. But it also, I guess, does have a bit of a risk in that it's a little bit unpredictable, which I guess you could also say like makes it more natural. That's like how humans also it's a little unpredictable, like what humans remember. But yeah, basically it's up to the LLM like what to decide, like what information it wants to actually save into its in context memory by, and it does makes that decision by calling a tool. So we basically provide this tool that's we actually call it core memory in our system, but basically like core memory replace, core memory append, and then the LLM can basically specify which section of the core memory it wants to edit, so the human or persona section, and then is basically able to apply edits to that. But yeah, I think you can also even though we designed it this way in MemGPT, you can also do this in other ways. Like you don't have to have core memory replace or append. You can also have like basically rethink your entire core memory. So you can replace the entire thing, or you can kind of require like certain structures or certain constrain the way that you update that memory. So it's very like customizable to the developer. The only kind of big difference, I guess, is that the LLM itself is responsible for calling that tool, but you as a developer can kind of decide like what the definition of that tool looks like.
so okay, so Yeah, so you can bring your own kind of self-editing prompt. And I guess
Hmm.
so I kind of want to just double click on that. You mentioned these two sections of like human section and persona section. So like if I'm the agent, I have my persona of who I am as well as my human
Hmm.
of who Sarah is. So are these kind of like the two? So then I'm just so curious about this like self-evolving persona. I think that's such an amazing idea that the
Hmm.
agent is out there doing stuff and it's like updating its own persona. Uh,
Yeah.
what kind of like I'm for me that really like as I've been digging into Letta and the self, it gets me really interested in multi-agent systems because I think
Hmm.
about if they have a conversation, it's really like this group chat perspective, right? And it's like, but they're
Hmm.
learning how to be themselves, sort of as they're
Yeah. Hmm.
talking. Yeah, so I guess I just want to ask about your experience with like the updating the personas, what you're seeing, how you would maybe even rank that on the most. There's so many
Hmm.
exciting ideas in this, but yeah.
Yeah, well, I think when we originally added the persona, it was kind of to provide like self-consistency to the personality of the agent. So if the agent says something like, I love chocolate ice cream, and then like a week later you talk about chocolate ice cream, it shouldn't say like, oh, I hate chocolate ice cream and have like no memory of like something totally conflicting that it said before. So that was kind of why we made sure that there was also a part of the memory dedicated to the agent about itself, as opposed to just about the human. But I think one thing that we've kind of seen that's been pretty useful about the persona is that it's not only useful for the agent to remember things about itself, but you can actually also kind of use it as a mechanism for the agent to remember feedback. So we've actually played around with some examples where you're talking to the agent or the agent's doing something, and then you give it feedback like, hey, next time you send an email, like please like sign off on it in this way instead of how you did it, or like please like don't call this tool in this way. And so oftentimes when you give that feedback, especially for better models, they'll actually kind of make an edit to their persona to remember that feedback. And so what that means is that now it's in the in context memory. So whenever you call the agent in the future, that information is always, or like that feedback is always going to be in the context window. So the agent is actually able to essentially like learn from feedback in a human readable way by using that persona section of memory. So that's been like I guess like a pretty cool or like somewhat unexpected thing that we've seen.
Yeah, it's so cool. My experience right now is trying to train the agent to use
Hmm.
Weaviate's search APIs, and so you just go through the queries, and it just learns how to use the. It learns, oh, integer property filter is this, group by does this, and just learns from its
Hmm.
experience. I mean, this self editing, it really sounds like I'm curious if you think it could trigger, like it might want to trigger like a gradient descent update. It might want to change the weights or like because
Hmm.
maybe for a little, our last podcast we published was with contextual AI and Amanpreet Singh, and they talk a lot about one of the points Amanpreet made was production grade RAG. You're just getting so much feedback that the idea that you can put all of this into a prompt and capture that whole
Hmm.
distribution of feedback is just that's when it's time to pull the lever and say, hey, let's
Hmm.
encode some of this in the weights of the neural network. So yeah, I'm curious.
Yeah. I think we're definitely big believers in like pushing as far as you can within context memory. I think any like memory or feedback that you're putting into the context window, like basically formatting its prompts, has this like ginormous advantage, which is that it's human readable. So like I can go in and like see that the agent like wrote to itself like, oh, like I need to sign off on emails that I send on Sarah's behalf as like sincerely instead of like thanks or something like that. Like I can go in and look at it, right? And like I can even go in and edit it. So I think because of this, in context memory has or like prompt based memory, I guess, has really, really big advantages over things that are not really like human interpretable. I think too, like in general, with updating weights, like whenever you start to get into models and updating weights, it just becomes like a lot more operationally complex. Even before LLMs, there was like a lot of work in like continual learning and like, oh, can we like train models like online to kind of be like real time and always account for the newest data? That's like a really well explored like area of work. But I think a lot of that didn't really end up getting brought into production unless they were like in really, really advanced use cases, just because it's so hard to like get these things working or like to make sure that like the changes that you have happening inside of the model weights are like actually correct, because it's really difficult as a human to go in and validate that, right? Or like you have to make sure you have a data set that's like also up to date with the latest data to evaluate those like changes that are being made. Because yeah, with model weights, you can't just read the model weights and decide if they're right or not. You have to have a data set and a mechanism for evaluating them. So yeah, that's why I think for us, like we're really big believers in using the context window for memory and state as much as you possibly can, because the minute that you switch over to doing something more complex, your interpretability and like the operational complexity of your system just like really, really, yeah, degrades.
Yeah, I think that point is super strong. When I was kind of referencing that old podcast, Amanpreet was talking about, yeah, like you could do like mechanistic interpretability to kind of have this model
Hmm.
auditing with the parametric knowledge conflicts with what's in the memory, and it's like, yeah, like it's like cool, but also kind of like you
Hmm.
say, like extremely difficult to just like for most people. But yeah, it's definitely an interesting
Hmm.
emerging topic. Um, so
Yeah, I
so
mean, I
sorry.
oh sorry, but yeah, I don't think I don't want to say that I'm like totally against like fine tuning or like using weights. But yeah, I feel like I do really want to emphasize that I feel like we're just getting started on like really managing context windows or thinking in advanced ways about how to like what to put into context windows. Because if you think about it, like these past couple years, we've just gotten like better performance for free by models getting better and better. So we haven't even really had to think about like, oh, like how do we really optimize the context window? Or I mean, some projects have thought about that, but I think it hasn't been like a really big thing. But I think like as like model performance kind of like stagnates, that a lot of the work is going to go into like how do we kind of optimally compile this context window to represent all the state that we want to. So I think it's like a very like exciting and like new area.
Yeah, definitely. And yeah, I think also, yeah, just like the zero shot, I mean, just the models are getting so strong.
Mhm.
And yeah.
Yeah.
And so then I'm curious, maybe quickly, if we could touch a little more on that context compilation. Something I'm surprised isn't more popular is like always having a summarization of search results before you then pass it in the next step. So
Mhm.
is that kind of like, so do you have this summarization inference? Is that kind of like how that works?
Yeah, so I think for us, like when you do an external, everything in Letta is basically tools, right? Like the memory management is tools, the search is tools. So if you want to do something like connect some external vector database or maybe connect like Google search to your LLM, you basically do that through a tool. So you can actually, once you get the results inside the tool, actually just send, before even returning back the result to your agent, just send back query all the results with like some LLM model and then just summarize the results and like return the summary in addition to the results if you want to. So it's like very configurable just because yeah, everything is tools, and so you can like put in like whatever code that are like additional processing that you want to inside of your tools.
Yeah, wow, super cool. Yeah, I love the tools perspective. I think, yeah, like this function calling thing. Do you like the function calling sort of abstraction behind it? I think Berkeley gets the credit for that with OpenAI maybe as well. But I remember early on it seemed maybe less obvious that function. I guess even still I'm like, because I guess like alternatively to function
Hmm.
calling, you have a hard coded flow of inferences, and so these
Hmm.
are like the two things. So I'm curious. Yeah, I'm curious just like your perspective on function calling. Oh, sorry if I set this up wrong. Like, is that even how you think
Hmm.
about tool use? Is it this function calling framework? Yeah.
Yeah, I think the way that MemGPT and also Letta, the way that we designed it is that everything the LLM does is a tool call. So even sending a message is actually a tool call where the agent can specify like in the keyword arguments, like the reasoning that it makes to itself, and then also like the message that it sends to the user. And yeah, I think this kind of helps with the design or like also with like making things kind of model agnostic, because if you just have everything defined as a tool call, then it's very general purpose. Like you can build like a workflow agent, you can build an agent that chats with you by having like an explicit like talk to the user tool, and then you can also even like implement multi-agent. So the way that we think about multi-agent is it's actually just agents talking to each other. So you can have a tool where the agent can broadcast a message to a bunch of other agents. You can have a tool where the agent sends a message and like waits for a response, sends a message and doesn't wait for a response. So I think tool calling is just a really nice primitive to work with because you can build on top of that. So yeah, I think that's kind of like how we've designed the system from the get-go.
Yeah, well, that kind of send a message, don't wait for the response. It just makes me think of all this kind of like
Mhm.
async multi-agent architectures that we're probably going to see. And
Yeah.
yeah, and so sorry if I'm jumping around the topics a little bit. I wanted to maybe come back to now maybe introducing the agent development environment could be really cool. So yeah, this is when I first took a look at Letta for myself. I thought it was so cool how you have this GUI that has all these things. Yeah, like you mentioned, you could define your own prompt for the self editing or bring your own tools. And yes, I guess I just
Mhm.
want to kind of open the box and maybe kick it off by asking broadly about, yeah, like what is the agent development environment?
Yeah. Yeah. So I think at Letta, just to give some background, like we really are trying to like prioritize the developer experience because these agents aren't like simple to develop or simple to understand, right? And I think it's very difficult to kind of visualize what's going on just because there's so many components like tools, archival memory, like conversation history, in context memory. And so we want to make these all these like different components very clear to developer. And I think, we did look a lot at like other, like, for example, like the OpenAI, like assistance playground, like the various different playgrounds. But I think a lot of them, they have a lot less configurability just because they're much more like sort of black box systems. They don't let you control like the memory, or like, yeah, basically like, or like execute tools on the server. Like, I think you have to execute like tools yourself. So that's kind of why we like, given our framework and our way of doing things with Letta, really thought very carefully about like what's kind of the best way to present all this information to the developer and allow the developer to basically like code their agent in a way that works really well with the Letta framework. So yeah, the agent development environment, it's actually built in we into both our desktop app, and then we also have like a cloud service. So you can go to app.letta.com and use it there and connect it to your local server, or you can actually just use the desktop. And in both cases, you'll get like the same UI. But yeah, it's really meant to kind of allow the developer to understand like what are all the things inside of the context window. So we have like a context window viewer where you can both like toggle the kind of budget of tokens in your context window. So you can, even if you have like a 200,000 context window, you can set it to like 30K. And then you can kind of see like, how are different parts of the context window being allocated. You can also see things like your in context memory, your archival memories, and watch them be edited in the UI. And yeah, we're actually also recently adding something that we're calling tool rules. So basically like applying constraints on like if the model calls this tool, or sorry, if the agent calls this tool, then it must follow with this tool, or like each time you call the agent, it must start out with calling this tool. So yeah, we're also adding like visualizations for those rules. So yeah, I think like the agent development environment is something we're really excited about. It's a very, very different experience of developing agents than I think like anything else that I've ever tried. So yeah, people should go check it out.
Yeah, definitely. And so I guess so again, just so many cool ideas. So I've maybe take them down one at a time. I guess maybe the first question I have is maybe the like hottest take question, where I'm kind of curious about the distinction between this, and then we saw this like kind of huge market of like LLM observability companies like
Hmm.
Arise or Galileo and all these ones that I won't name
Hmm.
them. But so I'm curious, kind of like yeah, like how because it obviously differs from just logging the traces because you can update the agent within the platform, whereas with these
Hmm.
observability tools you can't do that. So I'm curious, maybe if you draw a lot of inspiration from those, or if you still try to, you know, you still say, hey, you can also use that to monitor the traces while use the agent development environment to like update your agent. Is that the right way of thinking about it?
Hmm. Um, yeah, so I think a lot of so I definitely think, observability is really important for agents, but I think a lot of the need for them or like the immediate need for them, like during development that comes, like that arises is due to the fact that a lot of frameworks are very black box. So if you're building your agent in some framework and you want to know like what's the actual context window being passed to the LLM, I'm sure this like depends on the framework and I haven't tried all of them, but in a lot of cases, it's actually really hard to see. Like they don't make it like obvious like what is the actual like context window that's being packed and sent to the LLM. And I think that's like a huge problem for a developer because if your agent again the context window is everything, right? So if your agent does something weird or like it's missing some memory or like forgetting something, it's really hard to debug that unless you can view the context window. But that's just like not really something that a lot of these frameworks support really well. So I think that's why a lot of these observability platforms have come out, just because they have kind of put in all the work into making things really transparent and collecting all the data for the developers in a way that I think these other frameworks haven't. Um, so yeah, I also think what that means though is that if as a framework you make the context window really clear, you make really clear to the developer like what is actually happening behind the scenes with the agent, then I think there is still definitely like a role for these observability tools, like in production and like after deploying. But I think like in the actual process of creating and designing the agent, it becomes like a little bit less like of a absolute necessity because in my opinion, you should be able to immediately see like what is the effect of like changing some parameter in your agent. You should be able to see like how is the context window different now? Like how, can I like basically refresh like as I make a change and kind of immediately observe the differences in my agent, both like in terms of interacting with it and then also in terms of like what the context window looks like. So I think, yeah, I think there's a role for observability, but we try to make like that information like really transparent inside of the ADE itself.
Oh, it's amazing. Yeah, I love that way of thinking about it. And it kind of reminds me of like maybe of citing these Berkeley projects, but like chatbot arena or the agent
Hmm.
arena, where, yeah, I might want to just quickly see if I switch out O3 with GPT-4o, like what
Hmm.
kind of responses. And yeah, wow. So building that kind of,
Yeah.
wow.
Yeah, exactly. And yeah, we don't have like, like a pairwise comparison like Chatbot Arena does, but it's exactly those kinds of changes that we want developers to be able to play around with. So you can have an agent be chatting with it and then just change out the backend model. And you can either like refresh the simulation inside of the ADE or even continue to talk to the same agent that has the exact same state, but then is just using a different model. And you'll actually like often immediately see like personality differences. Like I think like Claude that they like to are I guess I some people call Claude like a he, but I guess like Claude, like he likes to like often have like, oh, like I'm blushing or like I'm thinking and like have like these like italics about like what it's like thinking. Versus like yeah, it's like very playful, I guess, versus like I think the OpenAI models are don't do that kind of thing. So you can actually immediately see like changes in the way that the agent is acting from like what backend model you're using.
Yeah, wow. And yeah, I guess it's like that the vibes check versus, and then maybe also building in that kind of like you have like a evals set. Do you think about
Hmm.
that kind of thing, like how yeah evals might be integrated, like
Hmm.
50 to 100 or so? Yeah.
Yeah, I think evals is something we're definitely thinking about. Like one thing with Letta is that yeah, I guess we haven't talked about this yet, but like Letta is kind of a unique framework because all state is persistent in a database. Even like the in context memory, we actually call it like each section of the in context memory blocks. Those blocks are also like have like a corresponding database row. Also, all the conversation history, all the archival memories, all the like agent definitions and tool definitions, they're all just like rows in a database. So I think because you have this like really granular data storage, it makes it kind of like sets up your data in such a way that it's a lot easier to kind of go back and like debug like why did I get this result or like what were all the configurations and like what was in the context that like led to this result happening. So I think we're pretty excited about doing like more stuff with like evals, but I will also say that I do think vibe based evals is like a thing. Like a lot of the things that people are building with agents, like for example like a personalized chatbot or like a companion, there's you can't really like make evals for that, right? It's almost like a matter of like taste and like design to create these agents. So I don't think it's necessarily like a bad thing to not have evals. I feel like people often think like, oh, if you're doing AI, like you have to have evals. But I actually kind of disagree with that for like some cases. Like I think a lot of building AI can actually look a little bit like building product or like designing product. Like it's not about evals, it's about taste. And so yeah, that's kind of also again like why we think that a lot of evaluation happens through just like simulating things or like playing with things and making that iteration speed really fast for developers as opposed to like kind of just focusing on like I guess numeric evaluation.
Yeah, I definitely share that perspective. I think that like this whole deep learning history has been like these massive data sets where it's like
Hmm.
200,000 question answering, and then we
Yeah.
saw like the vibes thing, and then now it's like okay, how big is it going to be? And you have the cost of inferences, and it's kind of like the large size gives you like a distribution score, but it's like yeah,
Hmm.
what does that really mean to me?
Yeah, and I feel like it's so hard to kind of trust evals these days too, just because the models will be like really good at like some particular things that aren't like actually like reflective of like the ways that you want it to act in a given situation. So yeah, I do think oftentimes the best evaluation is just using the agent and seeing how good it is.
Yeah, super cool. Awesome. So I got a little distracted on my questions from the original discussion of ADE because I wanted to zoom into that idea of, yeah, connecting the agents to the database. It's like our favorite topic at Weaviate. We
Hmm.
want to try to like weave together AI and databases. And so I guess one another kind of like the Berkeley papers is GoX, this Gorilla runtime that
Hmm.
kind of has like this transaction support. So sometimes if the agent is writing to a database, you might want to roll it back. And so just designing
Hmm.
the environments this way. And yes, I guess maybe one more kind of thing I just want to maybe set the context with is there's another startup called DBOS, which is about like having this
Hmm.
like transaction support, particularly for workflows. And it's saying, hey, if you have a workflow, you need to use something like Amazon SQS or Temporal. You could just
Hmm.
keep saving it in a database. And so I guess sorry that I might have set this up by just talking for a while, but I guess I'm just curious about like what kind of things come to mind when you think about like a database for an AI agent.
Yeah, well, so I guess there's kind of two aspects to this. There's like the database that the AI agent like uses. So for example, the AI agent itself can have these tools to interact with the database to both like insert data and also like retrieve data back. But then there's also the database that the AI agent is kind of built into. So with Letta, we actually think of agents as services. So in order to use Letta, you actually, it's a little bit inconvenient, but you have to either run our desktop app or run like the Docker service or connect to our cloud. And but yeah, the reason why it's service oriented is because like we build agents in the same way that you would sort of build like fast API or like server applications. Basically, you have like a database that manages all the state, and then any like agent step is basically like retrieving state, compiling the context window, getting back an inference, and then passing like any state updates back into the database. So yeah, because of that kind of model that we have of like basically agents are a REST API service, they should be built on top of the service, not like separately deployed. We kind of like, yeah, manage all the state in the database, which, yeah, I don't know if you would necessarily call that like a database for agents, because in terms of the actual like software design patterns, it looks like any other piece of software. I don't think it's actually that unique. Like if you're building like a server for your user data or something, like I think you would design it in like a very similar way. I think we just from the get-go didn't really understand like why a lot of people were kind of treating agents differently. Like, we've been using database tables to manage state all this time. Why all of a sudden are we just like serializing our entire like application state into like a JSON for like just agents? Like agents are just like the same as other applications. So yeah, I would kind of like divide it into like those two scenarios where I actually think for the actual like service building part, it maybe matters a little bit less like what kind of database you're using. It's more just whatever you're comfortable using your application in, versus obviously like for data that's for agentic tool calling, you'd want the data to kind of or like the database to be kind of friendly to the agent. So like using things like embedding based search.
Yeah, I guess I may be curious if like there could be like a caching layer because like if I'm always going to be persisting my working context, I'm going to always want to access it quickly. Like if I'm an AI agent,
Hmm.
and then I guess maybe I don't know if this is just kind of plugging the Weaviate thing too much, but like one thing that we had like made a big deal about was like this multi-tenancy design where it makes it easy to create multiple like kind of instances of a collection as long as they share the same schema. So I think about like
Hmm.
all the agents might like have the same kind of schema for their like maybe you just kind of have like memory and then like timestamp, and so then you can
Hmm.
have this like multi-tenant scaling. And yeah, I don't know. I guess I'm just I
Yeah.
think definitely a cool topic. I think thinking about what might like AI database and
Hmm.
all these kind of things.
Yeah, yeah. I mean, yeah, I think it all like ideally is like connected through tools, because then yeah, basically regardless of how the agent's built, you can always like connect it to like this data source, or it's almost kind of like working memory that's like not inside of the context window. Basically, this like external storage. We call it archival memory in Letta, but basically this like external storage which you can insert data into, like retrieve from in whatever kind of way that works best for your application.
Yeah, and so I guess it's kind of breaking off from like the database that's more particular to your application, but I kind of think of web search as kind of like an external tool database. And
Hmm.
I'm curious how core you're thinking this is to these Letta agents, because I imagine with a lot of Letta agents, if I say, you are a market researcher on LangChain, you follow everything LangChain does, and then
Hmm.
like so its first step would probably be to use web search to like, and then use that self-editing update. So I guess
Hmm.
maybe my question to you is, yeah, just like of these external tools that you're pairing with the Letta agentic architecture, what are some of the most effective examples?
Hmm. Yeah, well, I mean, web search is definitely one of them. I also think a common one is wanting to retrieve from some external data store, but then wanting to do it iteratively. So oftentimes you have like some huge like external data store. Say it's like a database of like user transactions or something, and you want your agent to actually understand what's in all of that data. So obviously it's not all going to fit into the context window, but if you have like some kind of paginated search, then you can basically like page through all of that data and then use the in context memory to kind of learn information from it basically. So like, you call the tool to on the first page of results, second page of results, the third page of results. And each time you get back those results, you kind of like derive the most important information or like update your in context memory about like what you saw on the last page of transactions. So I think like that's been like a pretty interesting use case because you can kind of like get LLMs to interact with external data in a way that doesn't rely on just RAG. Yeah, and then I think too, like it is very fun to like connect agents to tools where they can actually do things like write emails or like actually like text you or something like that. Since yeah, it definitely makes like agents feel like they're kind of coming alive.
Yeah, it's kind of funny to me that like the purchase of flight ticket used to be such a popular way to explain that,
Yeah.
like bring it to life by having it buy
Hmm.
you a plane ticket. But yeah,
Yeah.
yeah. So what I really I just am so fascinated by this vision of like I think it's got lang chains on my mind from the example I just referenced, but they had introduced the same kind of I think origin story where it's like we only have 4,000 tokens in the input,
Hmm.
so you're going to have to like parse through each of these documents separately, and they had this thing they called refine, which is kind of exactly like you say, where it's looks at documents one at a time and updates some like working memory of the documents. And I guess I just think about like because my interest in multi-agent has just exploded from looking at
Hmm.
Letta, and it's like I could have 10 agents that each look at like a different subset of my database and they each form
Hmm.
some internal memory from it and then they chat with each other to
Hmm.
see, is that maybe something that you think is
Yeah, definitely. Yeah, actually, so one pretty cool feature that we have in Letta, which actually goes relates back to the databases stuff we were talking about before, but basically, even because the core memory or the sections of core memory are like persisted into a database, you can actually create multiple agents that have like shared memory blocks. So that means that if you have like say you have like a organization section of your core memory and you have multiple agents that are basically attached to that, if any agent like makes an update to that memory block, then that change is actually reflected in all the other agents' context windows. So we kind of use for our multi-agent setups, we kind of use a combination of basically like these shared blocks or basically like shared sections of the context window plus like inter-agent messaging to basically like get that coordination working. So yeah, I think in like the use case you mentioned, you could definitely like have like multiple agents, perhaps like looking at different sections of some data set, and then having like a shared memory about like all the insights that they derive from that data.
Oh, that's amazing. That also remind that I think that ties into like if you have like this task first perspective of deep learning machine, like
Hmm.
where our task is like to classify these documents, and then we have this shared memory, which could be like our sort of like rule based system. It's kind of interesting. I see a lot of like people's perspective on prompt engineering is that you're trying to basically put a rule based system into this prompt, but so maybe there's that, but in that, and then you say, well, that doesn't scale if you've got thousands of examples. But this idea that all these agents are classification agents and they share this working context of like how we're going to classify these things, or maybe it's like their instruction of how to re-rank document or summarize it, like whatever the
Hmm.
task thing is. Uh, yeah, sorry, that was a bit
Yeah.
of
Hmm. Yeah.
a. But yeah, I guess that kind of it's like you could have this like they're like a chat bot, and so it's very open ended, or maybe it does some particular
Hmm.
task and yeah, you're a little more particular about
Yeah.
it.
Yeah. Definitely. Hmm.
Awesome. So I also really wanted to. Another thing that really stood out to me when I was looking at Letta is that you have your own models. So you come in, you have like Letta Mini and Letta embedding models, and so I really wanted to ask you about like how that ties into everything you're doing and how you see that evolving.
Yeah, so we actually, to clarify, we actually don't have our own models yet. I think we are interested in eventually fine-tuning models, but again, like as I mentioned before, I think when you get into model weights, it's a really big time commitment, and I think there's a lot more low hanging fruit and a lot more opportunity right now is at kind of like the innovating at the layer above the LLMs, like more the orchestration and like context compilation layers. We do offer like endpoints. We just call them like Letta free and Letta embeddings. But those endpoints are actually just like model routers. So we let users use that to kind of just get started with Letta. And we'll kind of choose the model that you use that we're actually calling on the back end. Yeah, right now it's like fairly simple, but I think this could be like a pretty interesting area over time because we have found that a lot of developers using Letta, they don't actually care that much about what the underlying model is. Like I don't think developers, I mean, it probably depends a lot on the person, but a lot of them are just kind of like, I want my agent to work well, or like I want the inference to be reasonably fast. They just kind of have these preferences, but they don't actually care like, is it like Gemini? Is it OpenAI? Is it Anthropic? So I think like that's kind of like an interesting like future direction for us, kind of managing that the actual like model selection because our agents framework is model agnostic.
Yeah, wow, it's really fascinating to me to hear that that you're using the model router because I would kind of think that like the internal memory or like the working content the context that is compiled might be like particular to one kind of model.
Mhm.
But so
Mhm. Yeah, I think you could structure it like that. Like you could imagine like Letta, if, for example, we see that certain prompts work really well for one model provider, or like basically we can get a lot of benefit by structuring the context window different for like Gemini versus Gemini models versus OpenAI models. I think if that were the case, yeah, we could probably like make it so that the context compilation is also like model dependent because right now the way that the context is compiled or like the system prompt that gets chosen is yeah the same regardless of like what model that you choose. I think part of the reason might be for that. I mean, my co-founder Charles might have more opinions on this, but it could be that like since all these models are trained on roughly the same data, that as the models all get pretty like generalized or well generalized, they'll behave pretty similarly, and so really like kind of optimizing the exactly what like the prompt says might matter like a little bit less. Like it might be more important just like what information you put in there. But yeah, I think that's like not really like clear yet. And I could definitely see us kind of like changing the way that we format the context window dependent on models. Actually, I think that is something that's kind of coming up with these reasoning models because the reasoning models expect a pretty different like format of their data. And then there's also this question of like, do you put the reasoning or like previous reasoning steps like into the context window? So that's actually something that we have started thinking about, like potentially structuring the context window differently if you're using a reasoning model.
yeah, that's a fascinating nugget that I had. As I mentioned, I was just reading the Stateful Agents blog post again, and as I saw that, I was like, "Oh, is there something new? Some new way of thinking
Mhm.
about input for content?" Maybe
Yeah.
I'm sure our listeners would be interested in knowing more about this. Like, so there's something new to how you structure the input for reasoning models, particularly.
Yeah, well, so I guess so Letta has actually always included reasoning. Like even if you looked at the very first MemGPT implementation, um, because the chain of thought work had already happened at that point, we actually required the LLM to always generate reasoning tokens before it called any tool. So if you ever use like the AD before, even before reasoning models came out, you would actually see that before every single tool call or before everything every any step that the agent takes, it'll always generate reasoning tokens. And it would also do this like regardless of the model because it was happening at like the prompting layer. But yeah, now that the reasoning models have come out and the reasoning tokens are actually explicitly returned by the model providers, we have had to think a little bit differently about how we structure that context window because historically we've always put like the full message history into the context window. So that includes the reasoning tokens. But if you look at these reasoning models, the amount of reasoning that they do is just like obscene. Like it just keeps on rambling and rambling. I mean, it's kind of like fun to watch, but it also feels very impractical because it's basically it rambles for like a full like paragraph and for like the simplest things, right? Like especially with like Letta where like it like might need a call send message or like call like core memory replace. It'll like think for so long and like go back and forth for like the simplest things. Um so yeah, I think because of that, it doesn't make sense to always put in like all the reasoning tokens because you would just have like for every single like step that happens with the agent, you would have like a ginormous paragraph of reasoning and then one tool call, another ginormous paragraph of reasoning and another tool call. So I don't think it makes sense to put all that reasoning in there. So there's kind of this question of like, well, do you maybe put in a summary of like what reasoning was done before that tool was called, or maybe you just take it out? I think like with OpenAI, they I think in their I mean, it's not very clear, but I think in their documentation, they actually don't include the reasoning tokens in the context window on like future steps. So yeah, it's kind of like an open problem, and I think it'll like become more clear as people play around with these models, like what like the best solution is.
Yeah, well, so if I have a function calling agent, and with the initial prompt, it goes on this rant about thinking, and
Hmm.
so then it gets the tool call, and then this next inference where it's got the results of the tool call, it's not going to be looking at those reasoning traces because.
Yeah, or it's like basically a question of like, do you want to put in the like the huge like paragraph of reasoning into the next? Because yeah, usually you have like the full like message history when you make the next request to the LLM. So yeah, it's kind of like a choice of like it kind of once again comes back to the question of like how should we be compiling context windows?
Yeah, super cool. And it also even inspires my interest further in the agent development environment where you say, I want to see some of these reasoning traces. And then that's kind of
Hmm.
why I think I asked that earlier question about the intersection with the observability and the traces, because I imagine they're also kind of thinking like that. But the way that, yeah.
Yeah. Yeah, so I guess that's another thing too. It means that because right now in the Asian development environment, we show like the full reasoning and the message history that you see in the ADE is the same as like the message history that the agent sees. But we might actually want to have well, we already do have like debug mode and like different modes that you can kind of view the message history in. So we might make it so that maybe in like debug mode you can see everything, but then in like interactive mode, you see what the agent sees, which is like something more concise. But yeah, these are kind of yes things that we're still thinking about.
Yeah, so cool. And I guess I'm also curious, like, so maybe like if you would call it this, the first generation of agent development environments might have been things like, oh, I can't remember the exact name of this. I think it's called Langflow. It was acquired, I think, by DataStack.
Hmm.
Sorry, I can't remember quickly, but it was kind of like
Yeah, are
about
these like the like drag and drop things?
yeah, yeah. So do you take any inspiration from those kind of things, or like yeah, like I guess maybe like a GUI
Hmm.
connected to tools and process like yeah.
Yeah, yeah. So I think like our view on the Asian development environment is more so like we want to stay tied to the core abstractions, right? And like the core abstractions of LLMs is that you have a bunch of tokens, you pass it to LLM, and you get back a bunch of tokens. Like that's it. And so I think we really want to stay like tied to the fact that like everything that you're configuring in the ADE is basically configuring the context window. And we want to make it clear to the developer like if you change like this here, like this part of the context window changes, or like if you configure like the limit or the size of this memory to be bigger or smaller, it's going to change like this portion of the context window. So I think because of that, we don't really. I think when you get to like more like graph-like representations or more like kind of drag and drop component representations, at least for me, it starts to become very difficult to understand like, well, how does this visualization that I'm seeing actually translate into what's going to be passed into the LLM's context window? And so I think that's like yeah, a bit of a difference between like how we think about the design as opposed to like a lot of other like visual interfaces for building agents.
Awesome. Yeah, super cool. So sorry that this is definitely jumping around a bit. But I just have like a couple of my notes from earlier that I would just want to touch on. Which, so one thing you mentioned is the idea of, yeah, still on the topic of the agent development environment. So not going too
Hmm.
far off, but you can bring your own tools to execute on the server. I think this is a
Hmm.
pretty trending topic of like I write my own Python function, but yeah, and so maybe earlier I'd mentioned Anthropic's model context protocol that you kind of connect with Cloud Desktop, and then you can
Hmm.
like you write the code local, and it's because it's locally, and that's kind of like how it works. And so I'm curious with so executing tools on your server. There's maybe things like SQL injection or
Hmm.
like what I guess like I'm thinking like what could go wrong.
Yeah,
But
yeah,
yeah,
yeah. There's a lot of things that could go wrong. Yeah, so I guess just to provide like a bit of context on tool calling, because I think this is a very common point of confusion, even for like myself when I was first learning about it. But basically, when you define tools for your agent, like say I define a tool on OpenAI assistants and like it like runs a tool, it doesn't actually like run the tool. It basically just returns back a request to run the tool. So it will specify which tool it wants to run, the arguments, but then you as a developer like have to figure out like how to actually make that happen. So I think in contrast with Letta, we actually will do the tool execution for you. Because I think it's just really difficult to design systems when you're like trying to go back and forth. Like the agent inference happens here, but then you call the tool over here, and then you go back to the agent inference. It's a lot nicer if you can just like define the tool on Letta, and then when the agent calls the tool, it also runs the tool and then like continues to execute. It's just like a lot more convenient. And then also another nice thing about this is when you're developing tools on the ADE, you can actually like iterate on the tools on the ADE. So you can like change the code, you can like change the arguments, the tool name, the response format, and then those changes are actually all reflected immediately, and you can kind of like test them out before even attaching them to the agent in like what we're calling the tool editor. And that's all possible because we're managing the actual like execution of the tools. So of course, like you said, there's a lot of like challenges with this, right? Because I think when you're running tools, there's a lot of things you want to be able to configure. So you want to be able to configure like some environment variables that in that like tool execution environment. You probably want to be able to configure like different like Python packages that you want to import. And then of course, there's also security issues. You could probably do very dangerous things like deleting files from Python, which we would really not want you to do as Letta running the server. So what we do is we actually use like tool sandboxes. So we use something called E2B. There's also I think like Modal also has something similar, but we basically have save the Python code that the developer gave us for the tool definition, and then send that code to E2B along with like any environment variables, any like additional like packages we want to install, and then that code gets run, and then we get back the response, and then like basically append that to the message buffer. So that's how we handle like tool execution. If you're running Letta locally, by default it won't use a sandbox just because it is a little tricky to get all this stuff configured. That'll just like run locally on your machine if you're just using Letta locally. But yeah, if you're using Letta Cloud, then we do like use sandboxing to ensure that you don't break our server.
Yeah, it's awesome. It's so cool to learn more about how that works. And yeah,
Mhm.
I've heard about E2B for a while, and I'm curious about. And I saw the modal sandbox. Yeah, all that execute the tool. Sorry, I just lost my train of thought randomly
Yeah,
about
yeah,
the
I think
about
it's a
the
very
tool.
interesting area. Yeah. Mhm.
Yeah, awesome. Oh man, I'm sorry. I'm gonna see if I can remember it. I don't know, but yeah. So I guess like just rambling a bit. Like this had led to I think like maintaining like the client connections with running tool because usually like you'd have like Weaviate client, and that led to like this dependency injection. Is kind of
Mhm.
like the story of how this was all designed, and yeah. Anyway, so yeah. So that the tool topic, I think that's a pretty exciting one about how you execute it, how you think about maybe. Oh, okay. Sorry. This is what I wanted to ask you
Mhm.
about. So I had interviewed John Yang and Carlos Jimenez from SWE Bench, and
Mhm.
they describe how they use a ton of Docker environments for building these tool environments. And so I'm curious,
Mhm.
like, I guess my question is just, you mentioned a bit about like we have tool sandboxes. I'm just curious, like how difficult it is to create these environments that the tools run in. Like maybe here's an example, like with Weaviate, we use a version of Protobuf that doesn't work with like Google uses a different version. And so you have to
Mhm.
have two different environments. So maybe that's the big issue I see with tools.
Yeah, it definitely does introduce a lot of challenges because you basically want to make it really easy for developers to recreate the environment that they have locally that they're creating their tools in on the cloud. So yeah, I think you can do like basic things like allow developers to specify like environment variables and like packages for their tool execution environment, but yeah, there's always like something that happens that like causes the environment to be slightly different, which can make it a little trickier. It's definitely like something we're trying to like work on to make it as easy as possible for developers. But yeah, I think it is like one of the challenges of running agents as a service and then trying to do this like secure tool execution. I think for us too, because we're like a service oriented model, you do actually, the main way we recommend people running Letta locally is through Docker. So if you're running a Letta server locally, like with Docker, you can actually like execute into the container and then kind of customize your environment in there. So that's definitely like something that's like doable. But yeah, it's like a little like inconvenient or like that's not. I think we would definitely want to like improve on that, make it like easier to kind of like link your local environment to what Docker's running with. Um, just so we can like make it a lot easier to like develop tools quickly and iterate on them.
Yeah, amazing. Well, Sarah, thank you so much. It's been such an amazing overview. There's just so many exciting topics around Letta, and yeah, I can't even say enough about how interesting this self-editing context compilation idea is, and then this stateful agents thing. I don't think you have two of the best
Mhm.
topics in AI right now. So I love anchoring the podcast with this kind of generic question of we've already discussed so many future-looking things, but just broadly, what future directions for AI excite you the most?
Um, yeah, this is maybe like a bit of a boring one, but I'm actually really excited about like agents' ability to like derive insights from data. And by that, like I don't mean just like, using RAG or like doing like traditional like analytics. It's more the fact that like these LLMs are like really, really like powerful models. And if you like give them the ability to be stateful and be able to like call themselves multiple times to actually be able to like look at large amounts of data, I think they can actually do really powerful things. Like in the same way that if you give like a human like a book or like give them like a bunch of like Excel sheets and they like read through it and kind of like derive information from it. I think we can actually get agents to do that as well. And yeah, I think historically, like deriving insights from data has always been something that's been like really, really useful across different domains and applications. So I think for me, like maybe again a bit of a boring one, but like that's what I'm like really excited to see because there's been so much like work that's been like historically done in that space. And I think agents could actually like make a big difference there.
So, and I'm sure, like with your experience as a scientist, that you're like I share this too, where I'm, running some experiment. And I've got my new data
Mhm.
table, and I'm like, there should be more AI involved in this
Yeah.
workflow.
Mhm.
Yeah.
Yeah, yeah, exactly. Yeah, like having AI be able to like look at data. Exactly. Mhm.
Yeah, and then I guess this would kind of transition on that topic too. I'm curious about like how much AI is writing your code at Letta, like just or you personally, like how your workflows are with it. Like if you're using Cursor or using anything
Mhm.
like a background task. Yeah.
Yeah, so I personally use Windsurf. I've used like I used GitHub Copilot for like a long time before that. Yeah, I like Windsurf's like agentic feature where you can actually like watch it do things in sequence. Um, I think I do wish that AI wrote more of my code, but I unfortunately still have to write a lot of my own code because a lot of what I do these days is like bug fixing or like really like specific things. I think a lot of our like base code base is kind of like written out. So unfortunately, I still write a lot of my own code, but I'm hoping that that will change.
Yeah, awesome. Well, Sarah, thank you so much for joining the Weaviate podcast. To all the listeners, I really hope you check out Letta. So many amazing things that we've been talking about throughout the
Mhm.
podcast. Sarah, thank you so much.
Yeah, thank you so much for having me. Really appreciate it.